Bismillahirrahmanirrahim. Hello everybody and welcome to lecture number 21. That is about case studies or network diagram, CPM, PERT and EVM. So all this time while we were studying this theory part of thing, we are now actually going to apply what we have learned through these relevant sessions. So we will do network diagrams and then CPM and PERT, and then in the end earned value management, one case study. Okay, so let's start with the summary of what we have discussed the other day. Okay, so in previous lecture we were talking about the elements of earned value management system, and there are 4 of them: planned value, earned value and actual cost. These are 3 primary elements, and then 4th one is actually is derived from the last planned value part of PMB. Then how to develop performance measurement baseline. We have given it another shot in previous lecture as well. And then we have discussed in good detail about earned value management techniques and when to plan and when to use these. And then there are 3 of them: discrete effort, proportioned effort, and level of effort. So for different types of work packages in a single project, you may use different techniques for earned value crediting. Then we had discussed about a few matrices: schedule variance, cost variance, and indices like SPI, schedule performance index, and cost performance index. So negative schedule variance means we are behind schedule. Behind schedule, and we are and a negative cost variance means we are over budget. And if anything which is less than 1 for SPI means we are not using our time resources to the maximum, and anything which is greater than 1 is good for schedule performance index and cost performance index. And then we had talked about some forecasting things like estimate at completion, estimate to completion, and then estimate at completion time. And then we had this formula for understanding how much efficiency we are in need to bring our project back. And then by using all these concepts, we have done this one case study, and then we have talked about EVMS matrices. Generally we have given a bit very so there was a table, and on one side we were having schedule indices, and on other side we were having the cost thing. So if we are having lesser than 1 schedule performance index and cost performance index, that means our project is behind the schedule and over budget. And if we are having equal to 1 schedule performance index and 1 cost performance index, our project is on time, on budget. And if we are having greater than 1 SPI and CPI, then our schedule is ahead of schedule and below budget. Okay, so these concepts were discussed in that part of presentation. And now we will move towards the case studies. We have to complete our case studies. So so this is example number 1. We have to construct a precedence network diagram based on this data. So activity I follows activity B and precedes activity Q. Activity B1 precedes activity P and follows the completion of activities Q, K2 and E. So by going through that, let's start developing a good network diagram. So we are having activity B proceeds activity P and follows the completion of activities Q, K2 and E, and activity R follows the completion of activity B. Activity S2 follows activities R and S1 and precedes activity P. Activity K3 is preceded by activity X and L and Z and followed by activity G and F. Activity E2 precedes activities A1, X, L and Z. Activity B can start when activities A1 and X are completed. The predecessors to activity S1 are activity E, G and F. And activity E depends on activity L and E2 and precede activities N2, S1 and K2. And activity K2 follows activity N2, R and L. And activity P depends on activity R and N2. And activity S2 depends on activity X, F and E2. So we are having that information. Let's draw a table so that we can have better understanding of the stuff. Okay, so let's say we are having a table over there. Over there we can have so this is for activity and this is for predecessors. And again this is for activity, and so okay, so activity I, after going through this, we can identify activity E2 precedes activity A1, XL and Z, but E2 is dependent on nothing. Okay, so let's write E2, and E2 is dependent on nothing. Okay, and then there are A1, X, L and Z, A1, X, L and Z. So they are dependent on E2. So E2, E1, A1, X and L, they are, and then Z, E2. Okay, so we have and this is dependent on nothing. Okay, so then we are having this I follows activity B and B. R follows the completion of activity B. Again we have to find B. Activity B can start when activities A1 and X are completed. So B is dependent on A1 and X, and we have done A1 and X. A1 and X has been already done. So B is dependent on two activities, and that is A1 and X. Okay, so then we find out which one is next. So I is Q and B and B1. Then we find out, okay, so there is an activity K, K2 and K3, and so activity K2 follows activity N2, R and L, and K3. So we have to find where is K3. Okay, okay, K3 is preceded by activities X, L and Z. So X, L and Z have been already done, so we put K3, and this is dependent on X, L and Z. Okay, so K3 have been done. Then comes what is the next one? So this is done. E2, this is done. These are done. These are done. So we have completed this part. Okay, and K3 is done. Okay, and E2 is done. Then next is E. Okay, where is E? This is E, and activity precedes activity P and follows the completion of activity Q, K2, and E. So B1 is dependent on Q, K2, and E. B1 is given over there. So P1. So B1 is Q. B1, where is P1? Over there. Proceeds activity P and follows the completion of Q, K2, and E. Q, K2, and E. Okay. Q, K2, and E. Okay. So that is B and B1, and now we are having B drawn and K3 drawn and E. Activity E. Activity E is depends on activity L and E2. So L and E2 are L and E2, right? Okay, so we have identified 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 activities we have identified so far. So let's complete the remaining table in same fashion. Next one is N2, where is this has been done, and N2, and this is N2, and K2 follows activity N2. P depends on activity R and N2. So activity P, let's write activity P, and that is dependent on R and N2. R and N2. Activity P has been drawn. So activity depends on activity R and N2. And similarly, we have P, and now we are having N2, and N2 is dependent on E, and similarly we are having G, and we are having F, and then we are having R, and then we are having I and Q, and then we are having K2, and then S1, and then we have to extend our table a bit. Oh, then we are having S2, and then we are having B1 has been drawn and P has been drawn. Okay, so G is dependent on K3, F is dependent on K3, and R is dependent on B, I is dependent on B, and Q is dependent on I. Let's check. Okay, I follows B, and okay, that's good. Q is I. Q is dependent on I, and where is it? Okay, so that is okay, and then we are having K2. K2 is follows activity N2, R and L. So that has been done. So K2R, N2 and L, and S1 is dependent on F, G and E, and S2 is dependent on S1 and R. So that's it. This is the start of our network diagram. So we will have this thing, this boxes thing, okay. So if we draw one box over there, and that is for E. E2 is dependent on nothing, so we'll put E2. And then there is another box. There are 4 activities which are dependent on E2, okay. So we will identify four activities which are dependent on So we construct our boxes. In that fashion we can actually have E2, then this one is A1, and we have done that, then X, then L, and then we are having Z, so we are having this thing. So that is dependent on E2. Okay, so we have completed this, okay. So all these are done now. And B is dependent on A1 and X. So A1 is over there and X is over there. So this is another box, and that is for B. So B is dependent on A1 and X, so we put relationship arrows over there. So that is B. And then we are having K3, and K3 is dependent on X, L, and Z. So this one is, this has been done, this has been done, this has been done, this has been done, and K3 is dependent on XLZ, XL and Z, so we put K3 over there, right? So now we have put K3 over there, and that has been done. Now we are going to talk about B1, okay? So B1 is dependent on Q, K2, and E. So we do not have E, K2 or Q, so we are leaving, and E is dependent on E2 and L. So there would be somewhere, okay, over there we are having this thing that is called E, and that is dependent on, and so E has been plotted. Now K2 and Q are required, okay. So Q is dependent on I, and I is dependent on B, so we put over there one box for I, and I is dependent on B, so that has been done as well. And there would be another box, and that is for, and that is R, okay. So and that is also dependent on B, so R has been plotted as well, okay. So now Q is dependent on I, so there is another box in front of, and that is called Q, and that is dependent on I. So Q has been done, and now we will move to R. N2, R has been plotted, but N2 and L has been plotted. So N2 is not plotted. If N2 is plotted, then we are going to, and N2 is dependent on E. So we must be having something over there, and that is N2, and that is dependent on E. So N2 has been done. And now we are having K3 is there, so G is dependent on K3. So we are having one box for K3 and G, and hence G is dependent on K3, so that is also done. Now R and N2 have been plotted, so P can be drawn. So P will be somewhere over there. And obviously we cannot draw such type, but you know, for the sake of exercise, I can draw arrows, something you know, curve, but you can actually do that stuff. Okay, so P has been drawn, and now we are left with F, and F is dependent on K, and K is dependent on K. Okay, let's see where we do have K. No, F is dependent on K3. There is no K. Okay, so F is K3. So where is G? Oh, K over there. So we can have another box over there for F as well. So F is also, so this has already been drawn. Okay, now K2 is dependent on N2, R, and L. So we are having this thing. Okay, so let's have a box over there, and this activity named is K2 and K2, and that is dependent on R, and that is dependent on N2, and that is also dependent on L. Okay, so this activity is dependent on 3. K2 has been drawn. Now Q has been drawn, K2 has been drawn, and E has been drawn. Let's have, so we are having Q, K2, and E. So we must have something over there. One activity should be placed over there, and that is called B1. And B1 is dependent on K2, and then Q, and then E. This has been drawn. Okay, and now we are left with S1 and S2. So S1 is F, G, and E. So we are having G over there, F, and E. So these are 3. So we put something over there. So that is called S1 and F, G, and E. So F, and then G, and E. Okay, so we have done that. S1 has been drawn. So which one is left? We are with us S2. S2 is dependent on S1 and R. So we are having R over there and S1 over there. So let's have one last box for S2, and we put one arrow over there and then this one over there. So this is how we actually develop our network diagram. Okay, so that is a practical example. Now we will have, let's say we are having durations with us. Okay, so A1 is 6, B, and so we are having E2 duration. E2 duration is, so we are having E2. Okay, let's say E2 is having duration of let's say 6, and A1 his duration 6, and X is having duration 11, and then we are having L and Z, and 5 and 2, 5 and 2, and then we are having BK3, B and K3, 8, 8, 8 and 8, 8 and 8, and then we are having E, E is 22, and then we are having R, I and G, R, I, 3 and 9, 3 and 9, so 3 and 9, and G and F, so where is G? Okay, 6 and 5, so 6 and 5, and then we are having N2, N2 is 2, N2 is having duration, and then Q and K2, Q and Q is 3, and K2 is 1, so 3 and 1, so 3 and 1. Now P and B1, so P and where is P? Okay, so B1 is 2 and 4, so 4 is and 2, and S1 and S2, and S1 and 23 is for S1, and S2 is 23 is for S1, and S2 is 1. Okay, so these durations are coming from the duration estimation of activity part of time management. Okay, so let's start with the concept of CPM. So we put 0 over there, and we add this 0 with this 6, so we are having this 6. Okay, so this 6 will go over this, 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 and this. If we add this 6 with that, so we are getting 12, and then 6 plus 11 is 17, and this 6 plus 5 is 11, and this 6 plus 8, and 6 plus 22, 28. Okay, so we are giving 12 is going over there, or so higher will we go over. So 17 is gone over there, and then we are having 17, so 17 will go over there, and then okay, so there was a mistake, we can have 11 over there, right? 11 plus, so that is 33. Okay, so this 17 will go over there and over there, so sorry, 17 plus 18, 25, so 25 and 25. Now this 25 plus 3 is 28, 25 plus 19, 34, and we are having this 17 plus 25, and now this G is dependent only on K3, so 25 plus 31, and this is dependent on, F is also dependent on K3, so 25 plus 5 is 30, and this is dependent only, N2 is dependent only on E, so 33 will come over there, and that will become 35. Okay, so we have completed this part of our network diagram. So this part has been already completed. Okay, now so Q is dependent on I, so put 34 over there, and 34 plus 3 is 37. And for this we have 3 activities, and that is 31, 30 and 33, so put 33 over there, and 33 plus 23 is 36 and 56. Okay, and this activity is the P is dependent on R and N2, so 35 will come over there, 35 plus 4, 39. Okay, and this activity K2 is dependent on 35 N2, so 35 will come over there, or so 35 will come over there, 11 will come over there, or 25, 28, so 35 will come over there, so this will become 36. And this activity B1 is dependent on, so this is 37, 36 over there, and 33, so we will take 37, and 37 plus 2 is 39, and this 56 will go over there, and 56 plus 1 is 57. Now this has been completed. This is open-end activity, this is open-end activity. Both activities are having no relationship with each other, but you know, this is forward pass. Now we have completed our forward pass. Let's have backward pass. So we put 57 this over there, and then we 56, and let's have 57, that is the maximum. So we are not going to transfer that, but 57 minus 2, and that is 55. Okay, so for backward we are taking 56, and this is we are transferring that 56 over there, and we are transferring 56 over there. But before we can actually 56 over there, we should have another values. So 55 and 55 will go over there, and let's calculate that. 56 minus 23, so we are having 33. Okay, and similarly, this will go over there, 37, and this is 37. Okay, that is 55. 55 minus 1, 54, and similarly, this activity will have 55, and this will have 52, and similarly this may have, okay, so we may have 54 for that, so we will have smaller one, 54 from that. Okay, and this 54 will go over there, 54 or 56 or this one. So that activity P is dependent on nothing, so we put again 57 over there, and 57 minus 4, so we are having 53, and then if we transfer that 53, 54, 56, so we are having 53 over there. And this activity 54, and hence this will also be 53. So 53 minus 2, 51, and 53 minus 50, and 55 for that, 51 and 33. So we put 33 over there. 33 minus 11, and similarly we can go backwards. Okay, so if we put 11 over there, and then this activity is dependent on, so if we complete that, then we can actually identify our critical path. So that is the big deal why we are actually doing. So 52 will go over there. 52 minus 9 is 43, and now we are having this, and this activity is dependent on this, so 33 will go over there, and 33 minus 6 is 27, and this activity is also dependent on, so this is 33, and 33 minus 5 is 28, and these activities are now completed. Okay, so this activity 43 will come over there, and for that 27 and 28, so 27 it will come over there, so that has already been completed. So 27 minus 8, 19, and 43 minus 8, 35. So for that either 35 will be having 35, so that is 35. For that 35 and 19, and we are having 19, and for that is dependent on, so we will take 19 or 11. Okay, we will take that 11 thing. Okay, so that is dependent on 19 minus 2, 17, 11 minus 5 is 6, 19 minus 11 is 8, 35 minus 6 is 29, and hence we will take the smaller one, 29, 8, 6, and so we take 6, and this is 0. Okay, so in this fashion we have actually taken up that thing. We have identified our activities on critical path. This is the critical path activity. This is the critical path activity, and this is then the critical path activity, and then this is the critical path activity, and this is the critical path. So as far as CPM is concerned, we are having total duration of 57, and our path of E2, then L, then E, then S1, S2 is on critical path. Okay, so this is the total good example of how we complete our critical path by using that. So again, we are having something like that, and then we are having another example. We can complete that example in a similar fashion. Okay, so let's have an example of a PERD. Okay, so we are having this activity table. Let's draw that before we can actually start. So we are having A, B, C, D, E, and F, G, and H. We will use this formula. So expected activity duration will be given as optimistic plus pessimistic plus 4 times most likely and divided by 6. So over there we are having 3 values. So for that activity A, we are having this thing 5 is most likely, 8 is pessimistic, and 4 is optimistic. So we will use that formula for expected, and then we are having formula for ST, and that is P minus optimistic divided by 6, and variance is equal to ST square, and that is P minus O by 6 square. Okay, so we are going to use these formulas as far as our. So if we complete that thing for A, B, and C, so we will be having. Okay, let's draw that table, and so this is EAD, and this is ST, standard deviation. Okay. So let's have that table before we can actually go and find out the duration of that total project by using PERD. Okay, we have to actually probable duration of the project, so there won't be a one single good duration for that project, but a range of duration will be available with us. Okay, so expected activity duration will be A if we put the values 0. Okay, so EAD for A is equal to 5 plus 4 times 5 plus 4 plus 8 and divided by 6, and 5 is most likely, 4 is optimistic, and 8 is pessimistic. So 12 plus 20, that is 32 by 6. So we are having this 5.33. So we put 5.33. Okay, similarly we can have the duration of B, C, D, E, F, G, H. So we will have B duration will be 14.83, duration of C is 9.5, and duration of D is 4.83, and duration of E is 15, then 10.5, then 168.5, and then 35.17 is the duration of H. Now we will have the standard deviation, and for standard deviation we will use this formula P minus O by 6, and hence standard deviation for A is 0.67, B 0.833, and for C similarly we can find out, then we can have let's say we are having a standard deviation of F, and there is 0.833, and G is 8.5. Now standard deviation is quite high for that activity, and H is 2.167. and similarly we can find out the standard deviation of that, but we are not, because the reason we are going to explain. Okay, so now keeping this thing in view, let's draw a network diagram. Okay, so A is dependent on nothing, so A will be the first box. So that is A. And activity B, C and D, they are dependent on A, so we will put 3 boxes over there. We have actually drawn this diagram in relevant session, but let's redraw that. As far as PERT is concerned, we can have a very good idea how to use that. So B, C and D, they are dependent on A, and B, C, D are there, and then E is dependent on B and C. B and C. So put arrows as well, okay? So B and C. Okay, so E has been drawn, and B, C, D, there is one F activity that is dependent on 3 activities. So that is F, and that is dependent on B, C and D. Okay, so F has been drawn. Now G is dependent on F, and that is G, and H is dependent on E and G. So that has been done. So now putting the durations over there, we are having 5.33 for A, B is having duration of 14.83, and C is having duration of 9.5, and then D is having 4.83, and E is having duration of 15, and F is having duration of 10.5, and G is having duration of 168.5, and H is having duration of 35.17. And similarly we can run that stuff, you know, 5.33, 5.33, 5.33 and 5.33. So this 5.3 has been translated, and now if we add these two values, we get 20.16, and then we get 14.83, and then we get 10.16. So what will come over there from that, and that the highest one, and that is 20.16, and from that 3, what is the highest one, and that is 20.16 as well. Now we add these values and we get to 35.16, and then over there we 30.66 and 30.66, and adding this thing up, okay, that is point, we are having 199.16 and 199.16 plus 35.4, we are having something 234.32, and 234.32 minus 35, 199.16, and we go 199.16 and 199.16. So for G we are having 30.66, and this is 30.66, and there 20.16, and this is 184.6. So what will go over there, and that is the minimum value, and that is 20.16, 20.16 and 20.16. So over there we are having 5.33, and there we are having 10.6, and over there we are having 15.33. So 5.33 will go over there, and over there we will get 0. So now we can identify the critical activities, and that is A, and then we are having B, and then we are having F, G, and H. Now you can see we are having standard deviation for these activities which we have mentioned: A, B, and F, G, and H. We use this formula, and the standard deviation of the project will be square root of summation of standard deviation of activities on critical path. Before we will take the square and then we will sum up. So that is that means we will be having like 0.667 square plus 0.833 square plus 0.833 square plus 8.5 square and plus 2.167 square. If we solve that, we get 8.875. Okay, so now we can tell what is the duration of our project, and that is duration of the project, and that was asked over there. Okay, so what is the probable duration of the project? So I can tell you that the project duration will be 234.32 plus minus 8.875. Now that is the duration. That may be more than 234 and that may be lesser than 234. So that is how we use PERD to find out our duration. So that is the case study for PERD. Okay. So let's move towards the last case study, and that is about EVM. Okay. So there is a project, and the duration of that project is 8 months. And from where we have get this duration through CPM or PERD. We have done 2 case studies, right? So that is total duration of your project, and then we have planned value PV. And how do we have these figures with us? As we were having a schedule through CPM or PERD and PERD, then we were having budgets through contract baselines, and those budgets were distributed among the durations, and then we had PVs, and then cumulative PV are given over there. Then after 4 months we have we had planned that in month 1 we will spend 1,000. After 2 months we will spend 2,000, including the first one. Okay, so figures are cumulative. Okay, so 2,000, and by the month 3 we could have used 3,000, and for 4th 7,000. So by 7th month we could have used 18,000, and 8th month we could have used 20,000. So this 20,000 is also a BAC, budget at completion, right? And then we are having actual cost, and after 4 months we are having cumulative actual cost of 8,000. And we have earned value. After 4 months we are having 6,000 earned value. So if we can write this thing up, so that is BAC. BAC is 20,000. And then what is the CPI at the end of the month 4? What is the SPI at the end of the month 4? What is EAC at the end of the month 4? What is the ETC at the end of the month 4? Okay, so what is PV at the end of the month 4? And that is 7,000. So PV, AC and EV. So PV is 7,000, AC is 8,000 and EV is 6,000. So the first part is what is, this is given. Now solution. So first part is what is the CPI? So CPI, we are having this formula EV by AC. So EV we are having 6,000 and AC we are having 8,000. So this is equal to 0.75. So we are using our cost resources up to 75%, and that is the project is over budget. Okay, so that is 1. Then 2, what is SPI? Okay, let's 2 SPI. So SPI is equal to EV by PV, and EV we are having 6,000 and PV is 7,000. So we are having SPI, if we calculate that, that becomes 0.86. Hence, that is less than 1. Again, the project is behind schedule. Now we have to find out what is EAC, estimated completion. So EAC is equal to BAC by CPI. So we are having BAC 20,000 and CPI is 0.75. So estimated completion is 20,000 divided by 0.75, and that is 26,000 approximate. Right. Now we are having estimated completion, and the fourth thing was estimate to completion at the end of the month 4. So we are having estimate to completion, and that is EAC minus AC is equal to, EAC is 26,667 minus AC. AC is given over there 8,000. So and that becomes 1866. Okay. We are having another formula, and that is ETC is equal to BAC minus EV and divided by CPI. So BAC we are having 20,000 minus EV we are having 6,000 and divided by 0.75. If we solve it, we are having 14,000 divided by 0.75, and we get 18,666. Okay, so let's discuss the results of this case study. So our CPI is less than 1, and hence the project is over budget. Okay, and we are using resources up to 75% as far as cost is concerned. Project is behind schedule as far as SPI is concerned, because SPI equals to 0.86, and we are using time resources up to 86%. Okay, and EAC, estimated completion, as far as cost is concerned, the project will be completed in 26,667 rupees if the units are in rupees. Now that is important. We were having that budget at completion of 20,000, but now we will be completing our project in 26,000. And for that we are in need of 18,666 rupees more than rather 14,000, because if we see, we had 20,000 and we have spent 18,000. We would have in need of 12,000, but our analysis is showing no, we are in need of 18,666, that is 6,667 rupees more than the budget. So this is how we have a good understanding of earned value. Okay, let's move ahead. So EVM case study part 2. Okay, so the same data is there, the same data we are available with, and we are having 8 months, the same plan value, same AC and same EV data. Okay, now what is the CV at the end of month 4? What is the SV at the end of the month 4? So we want to have again the same data, and that is BAC we are having is 20,000. And after month 4, PV4 is plan value is 7,000. AC4 after 4 months is 8,000. And then EV4 is equal to 6,000. So this is data we are having. Okay, so we are in need of CV at the end of the month 4. So CV is equal to EV minus AC, and EV we are having 6,000 minus AC 8,000, so we are having minus 2,000. And if we want to have a percentage as well, so we may have like but for that we are just asked about what is the value, so we will give 1. Okay, and then the second part is what is SV. So SV is equal to EV minus PV, and EV we are having 6,000, PV is 7,000, so we are having minus 1,000. So that is SV. Now part 3. Okay, now there is a very important part. If all the work completed in month 4 fails quality testing and has to be reworked in month 5, meaning that none of the month 5's tasks can be completed. So now 3A, what is EV at the end of the month 5? So for that planned value will be is 12,000. So we write planned value is 12,000 after month number 5. But all the stuff has been rejected, and but in 5th month we have completed our work for 4 months. So this planned value will become earned value, hence 3A EV will be earned value will be equal to 7,000. Okay, and what is actual cost? So we are having 8,000 for month number 4 and 4,000 for month number 3. So if we subtract, we get 4,000, and this 4,000 has been again used or has been again incurred. So we will add this 8,000 plus 4,000. So actual cost will be 8,000 जो कि पहले हो चुका है, और अब 4,000 आपको दोबारा वही काम करने पे दोबारा लगा है चौथे महीने का, तो आपने वो दोबारा किया तो आपका 12,000 आ गया. Now that is EV we have find out, and AC find out, and now CPI. So CPI at the end of month 5 will be EV by AC, and hence that is 7,000 divided by 12,000, and if we calculate that, we come 0.6. So remember the CPI in another example, 0.75. By that time, project was over budget, but the efficiency was 75%, and now that has been reduced to 60%, 0.6, right? So that is how we can use these figures for, and this is how we actually work out our problems as far as earned value management is concerned. Okay, let's have the summary of this session. This session was to actually carry out the practical example. We may have some errors, like the data apprehension may not be good for me, but you know, you do have the problem statement with you. You do have my solution, but that is, you know, we were having time frame constraints, so there may be some a little bit mistake, but you can correct with the solution I have given you after that thing. So if you are having a problem, you are having solution done by me, but then you are having again a solution from the textbook, so you can consult and you can have that. Okay, so network diagram was complex type of network diagram was constructed in this class today, and then we had learned how to create that CPM and use that to have the duration of our project, and then we had studied that PERT thing, and PERT actually gave us the probable duration of a range of the duration. And in the last but not the least, we had done 2 case studies on earned value management. That is a very important part of this project management thing. Okay, so when it comes to simple projects, you may not be using all these tools. Okay, so today we are concluding our very important part of course, and we are concluding scope management, time management, cost management things. And from now onward, we will start risk management and procurement management. But before we proceed further, you will appreciate this concept that the same tools are available, but for simple projects, they are used with lesser effort and they are used with lesser detail. But when it comes to complex projects, the same tools are used with so much variation and so much effort. So this is the basic concept of complex management complex project management. Okay, and so we end this note with Paulo Coelho, the Alchemist, very famous novel. So he's written over there, when we love, we always strive to become better than we are. And when we strive to become better than we are, everything around us becomes better too. So I change this text a little bit, and I state, when we commit, or when we show commitment, we always strive to become better than we are. And when we strive to become better than we are, everything around us become better too, and quite manageable too. So thank you very much. Good day, and Allah Hafiz.